All right. So we have a claim that A transpose A is symmetric, and then we recalled the definition. A matrix S is symmetric if the transpose is the matrix itself. We had some little example over here just because. And now we're going to see the icky way, which maybe Grayson's going to talk me through. What did you do to demonstrate this, the icky way?
Okay, so we started with a row picture of A.
Okay, so A is some rows.
Yes. And it could also be a column picture of A, but it doesn't matter.
Okay, so you started basically with some kind of picture of A.
Yes.
Let's see, and this was maybe n rows, I guess.
Yep.
Okay.
And then since we know that the transpose of a matrix just switches the rows for columns or columns for rows, we wrote A transpose is a column picture of the same matrix.
Okay. Cool. Let's see, and how many columns do I have here?
N.
Should be n. Yeah. Okay. And then what'd you do?
Well, we multiplied those together.
Okay, so you did A
times A.
You did A transpose times A is, and then we got, so we took this matrix here. And multiplied by this matrix here.
Yep.
Okay, and now I see why you picked the row picture for the first one. No, I don't, but whatever.
It's fine.
It's fun.
Okay. I just ignored that we picked the row picture for the first one, and I just put it together anyway. Ignore
okay. That. Hang on, let me do this.
Do the old switcheroo.
Yeah. So we're going to define A transpose as this matrix.
Good. That's a good idea.
And A is that matrix. And then perfect. We can grab our row picture here and our column picture here.
That's exactly what I did.
Okay.
And then, so you can see that if we multiply these together in the first place, we're gonna get A1 dotted with A1.
Okay.
And then we go down and we're gonna get A1 dotted with A2. And then A1 dotted.
I'm gonna do that the other way.
Okay.
So I'm gonna say that's A2 dotted with A1, even though that's the same thing.
Yeah, it's the same thing. So I don't know why you'd put it out of order, Joe, but it's fine.
Because I'm thinking about picking the column up and dropping it onto the rows.
Right?
So I'm thinking about the row dotted with the column as I go on that.
Okay.
Okay, so at the end here, I end up with AN dotted with A1.
Yeah, for sure. And then if we go through the row instead of the column, we'll see that we get A2 dotted with A1.
Up here.
Or A1 dotted with A2 is what I meant.
Yep.
And then down one we get A2 dotted with A2.
Good.
And it'll follow this same kind of pattern, right? Where the diagonal just is A1 dotted with A1, A2 dotted with A2, A3 dotted with A3, and so on. And then across the diagonal, you're gonna get a mirrored image, as you can kind of see.
I buy into that. So down here at the bottom corner, I'm gonna get AN dotted with AN, right?
Yeah.
And up here, I'm going to have A1 dotted with AN. And I think it's pretty clear that this is symmetrical. Okay. Yeah. So that's our method. You guys with me on that? So the reason I think this is the icky way is that writing this out and then having to say observe that this is symmetrical is a little shaky. Now Karen had a method that was going to be pretty slick. If we can get it to work, I think we can fit it in this margin right here. All right, Karen, what do you got?
It was like if we do the transpose of A transpose A, right? It should be equals, if it's equal to A transpose A, then it's symmetric.
Good.
And
Okay, so we're going to start with this, right? And then we're going to say, okay, so I want to transpose this product.
yeah.
So I'm thinking about this as a matrix A times a matrix B transpose, right? So what is that?
That's B transposed, A transposed.
Yep. And this is the crucial thing, is that they switch order. Right? So in this case, A is playing as A transpose and B is playing as A. So I just need to take those two matrices and switch their order. So this is going to equal A transpose, that's this one transpose, times, I started writing B, A transpose transpose. So this equal sign comes from this fact, right? You guys with me? All right. And then what's the slick thing here? So I got A transpose. What's A transpose transpose?
A.
Good. That gets you back to A. Oh. Cool. That's symmetric. Right? I'm thinking this matrix has a transpose that is this matrix. Ergo, symmetry.
QED.
I like that. QED.
God damn it. Stop that. All right. Either way is okay here. Right? I'm going to tend to prefer the slick symbol manipulation way because I find writing out big boxes of numbers to be a little bit tedious. But if you find writing out big boxes of numbers to be something that's like cathartic or comforting, or you feel like you have a better handle on it that way, go for it. It's all good. It often works. Cool. All right. Let's try another one of those. I'm gonna send you to breakout rooms again, and the thing I want you to fiddle with is this thing that's actually on the. This is from the. Oh, I'm gonna stop recording.